Hello everyone, welcome to the P1 Classical Mechanics lecture series. So here we are going to do a problem. So this lecture is called P108.8. So in this lecture, I'm going to do a problem. Okay, so a very basic problem using the applications of Newton's laws. So I'm going to set up the problem now. Okay, so let's go. So the first thing I'm going to say is that there is a pulley. Okay, there is a pulley like this, and the pulley is holding some mass, okay, on either side. So this has the mass, some say m1, right? M1 is here, and then the on the other side the pulley, right? There is another pulley. Okay, so this is better now. So another pulley, and this pulley I'm going to call this pulley A and this pulley B. Okay, so this has another mass. I'm going to call this m2, and there is another mass hanging here. I'm going to call this m3. Okay, m1, m2 and m3, three masses, two pulleys. Okay, this is the system. The pulley, each pulley has a radius r, and there is mass m1, m2 and m3, right, hanging onto these pulleys. That's all we know. And now what I'm going to what I need to find out. Okay, what should I need to find out? So I can find out what the acceleration of each of these masses. Let's say a1, which is the acceleration of m1, the first mass, and then you can calculate a2, right, which is the acceleration of the second mass, and then a3, acceleration of the third mass. I can do that, right? And also I can find out the tension in this string of A, right? This is the string A, and tension in A, and also the tension in B as well, right? Tension in the string B as well, TB. You can find them all out, right? So how can I do that? Okay, let's assume that M1 must be equal to some what 10 kilogram, and uh, m2 is equal to 2 kilogram, and m3 is equal to say 5 kilogram. Okay, so let's assume that. Now this is the problem. I need to find out the tension in both strings, right? Both strings T of A and T of B, which is the T of B is the pulley, this string, and T of A is the first string, right? T of A is the first string. Okay, and I need to find the tension as well as the accelerations, right? Acceleration. So how can I do that? So for that, what I'm going to do is that I'm going to redraw this problem with the two pulleys, right? Two pulleys here. Okay, anyways, so two pulleys just like that, and then I'm going to draw these strings, right? The strings just coming into that string, and I have the mass m1, and I have two masses hanging on to this pulley. This string, let's call this a string, and this is the B string, right? So there are two masses m2 and m3, right? M2 and m3. So this is the situation now redrawn. What I'm going to do first is that I'm going to say, so I'm going to use a tricky thing right now. Okay, so this is the only complicated part in this problem. Anyways, what I'm going to do is that I'm going to assume that this string is not going to extend, right? So string A will be the same after a movement and all that, right? So the string A cannot extend, right? It cannot change. So string A is going to be the same. So that means d of string A by dt is going to be equal to 0. Okay, similarly string B won't change. So d of string B by dt will also be equal to 0. So these are the two things. So how can I find the length of the string, right? The string, how can I find that? So for that I'm going to take the A as the origin, right? A as the this pulley as the origin, right? So this is my origin now. Okay, this is my origin. Now what I'm going to do is that I'm going to draw the distance, each distance. So m1 will be at some distance, this distance, right? So I'm going to call this distance what, L1, right? I'm going to call this L1, and the m2 distance I'm going to call this as the pulley, this second pulley distance, right? This distance I'm going to call this as L pulley, right? L pulley, pulley B, right? Then m2 and m3 are also there. So I'm going to redraw this. I'm going to redraw this in such a manner that we can now extend this string so that m3 is much farther, right? M3. So now m2 will be this distance, right? This distance I'm going to call this L2, and m3 will be this distance, right? This distance. So I'm going to call that distance L3. Okay, so these are the distances here. Now I have L1, L2, L L of the pulley, and L1, right? And L3. So these are the three distance. Now I have to write down what the S is, right? What's the distance is, right? So what is the distance of string A? What is the length of string B, right? So string A will have a length of this much length plus this much length, right? So that will be L1 plus LP, LP pulley, plus the curved distance, this distance, right? So that distance will be the, since the radius of this pulley is r, so that distance will be, the total perimeter will be 2 pi r. So that distance will be pi r, right? So half of 2 pi r, right? So that will be some pi r. Okay, got that. Now string B, that's a bit complicated. Now this distance, what is this distance? I'm going to use a different color. So this distance will be the L2 distance minus LP, right? So that is L2 distance minus LP. I'm going to write down that. So that is L2 minus LP. And what is this distance, right? This distance, this to the downwards. So that will be, right, the LP is to the center, right? So LP is to the center. Remember that I'm taking the center as the LP. So this distance will be L3, this, which is this distance, right? L3 minus the LP, right? So that is L3 minus LP. So that plus L3 minus LP plus the pi r, the same pi r. So it's pi r. So now we know ds by dt will be the same, right? It will be equal to 0. It's not going to change. The string is not going to extend itself. So now I can write down that ds of a by dt must be equal to 0, which is equal to dl1 by dt plus dlp by dt. This is a plus sign here. Okay, it's not equal to, so dlp by dt, and pi r by d pi r by dt, the radius is not going to change, so it's going to be the 0. So that's negligible. So that's dl1 by dt. So what is dl1 by dt, right? So l1 is this length, okay, the mass, for the mass m1. So what is dl1 by dt? That is just the acceleration of mass m1, right? So dl2 by dt will be the acceleration of mass m2, and dl3 by dt will be the acceleration of mass m3, right? So you can just say that the length, time rate of change of length, right? So you can say that it will be a2 plus some ap, right, must be equal to 0. So that's what the equation that we can take out of that. Okay, so now the next thing that we can do is that, so you can just say, sorry, a1 for the mass one. So a1, so now you can simplify that and say a1 must be equal to some minus ap, right? So AP is equal to minus A1, or A1 is equal to minus AP. Let's call this equation 1, right? Okay, so that's one thing. So I can find out now. I have some glimpse of the acceleration here, right? So I have some glimpse of the acceleration here. So if you take the derivative, this is just the length, right? So you have to take the derivative again, right? So if you want to find out the acceleration, you have to take the derivative again. D square L1 by dt square will be the acceleration, plus d square LP by dt square. I hope you got that step right. I just skipped it. Anyways, that will be A1 and that will be AP. So A1 will be equal to minus AP, right? So we got that. Now in the second case, the same thing happens, right? The second case, you can see SB is equal to, so DSB by different color anyways. DSB by dt is equal to 0, right? Is equal to 0. So that will be, okay, this is going to be a little bit harder, right? So you can just say it will be, let's look at it. So ds by dt is equal to 0, which is equal to dl2 by dt. Okay, if you want d square l2 by dt square, taking the second derivative, minus d square lp by dt square, plus d square l3, l3, right, l3 by dt square, uh, what, minus d square lp by dt square, plus the other thing will be 0. It's a constant. So now you got a uh, a1, sorry, this is 2, right, l2. So you get a2 minus ap plus a3 minus ap must be equal to 0. So now you can simplify that and you get a2 plus a3 is equal to what, ap, 2ap, right, 2ap. So you got that. Now you can just use the equation 1. Let's call this equation, okay, you can use the equation 1 where you know ap is equal to minus a1, right? So now you can substitute that back in and you get a2 plus a3, the minus will come in this side, so you can take it to the other side as well, plus 2a1 must be equal to 0. So let's call this equation 2. So what we got is that equation, we got an equation with a1, a2, a3, right? So we got an equation with a1, a2, a3, one equation, three unknowns, right? One equation and three unknowns. So you cannot solve that equation. So you need some additional factor to solve this problem, right? So for that I'm going to use the same thing, right? I'm going to use something more, much more. So you have the two pulleys here, right? Two pulleys, remember that pulley, two pulleys, and there is m1 and there is m2 and then there is m3, right? So three masses. Now what you need to do is you can use the Newton's laws, right? So F is equal to ma, right? So you can clearly see that there will be tension in this string, right? So tension will be in this string. So this string A has A and B. So A has tension TA and B has tension TB, right? It's connected string, so TA and TB. And the mass will be acted upon by the gravitational force, and you get m1g here and m2g here and m3g here. Okay, so three masses, three forces. So let's write down for m1. For m1 the force will be, so you can write down force which is ta minus, so I'm going to take the downside as a positive, right? So whatever that goes to downwards is positive and whatever that goes to upwards is negative. So you have a sign convention here. So ta is a negative here, so you can write down minus ta plus m1g must be equal to some what, m1 a1, right? So m1 a1, which is the f equal to ma part, right? So Similarly, you can write for second mass, you can write down that m2g minus tb must be equal to m2a2, and m3g minus tb, right, tb, which is the tb here, must be equal to some m3a3, right? So simple as that. Okay, now you can simplify this and you can write down that a1, right? So you can simplify this and you can write down that a1 must be equal to, right, a1 must be equal to some g. Okay, so you get g, I'm going to divide by m1, and you get g minus, right, g minus ta by m1. Okay, and a2 will be equal to g minus tb by m1 m2, right? Similarly, a3 will be g minus t b by m3. Okay, I got that as well. So these, I just simplified this, I just took the all the other things, okay, all these things to the other side and simplified it. That's very simple. Now what you can do is that you can what you can do now is that take the pulley itself, right? So if you take the second pulley, right, the first pulley is there, the second pulley, you can see that this is the tension of tension A, right, string A, and this will be the tension of two masses, right, two masses here. So these two masses will have some tension, common tension, tension B. So if you look at the pulley itself, only the pulley, you can see that the force is equal to some ma. So you can write down force upwards is taken as negative, so you can say uh, tb tb plus tb 2tb minus ta is equal to 0, right, is equal to m a pulley, a pulley, right, a mass of the pulley and a acceleration of the pulley. So m mass of the pulley is 0 because the pulley has no mass, right? So it's a massless pulley, so this is equal to 0. So now you can say that tb 2tb is equal to ta. Okay, what a wonderful result that you can use. Let's call this equation, what this set of equations, let's call this equation 3, right? So beautiful set of three equations, 3, and I'm going to call this equation equation 4. Okay, okay, now I got all that. Now what I'm going to do is that I'm going to take back what we have done earlier, right? Our earlier venture into the string, changing the time rate of change of string length, right? This was the equation, equation 2. So a2 plus a3 plus 2a1 is equal to 0. So I'm going to use that equation. So I'm going to use that equation here. So that is just a2 plus a3 plus 2a1 is equal to 0. Now what I'm going to do is that I'm going to substitute a2, a3 and a1 into this equation. Okay, so we got a2, a3 and a1 here. So I'm going to substitute them back into this equation. So you get g minus ta by m1 plus, sorry, m2, right, m2. Okay, ta is just, okay, let's okay, a2 is m2, right, so it's tb, okay, tb, and then plus a3 is g minus tb by what, m3, plus 2 times a1 is just g minus ta by m1, right? So ta, we got that ta is equal to 2tb, right? So I'm going to substitute that here. So you get 2 times what, g minus 2 times tb by m1, I guess, yes, m1. So this must be equal to 0. Now things are getting much better now, right? So things are getting much better now for us. So you can simplify this equation. I can take the g outside, so you get 1g here, 2g here, and then there is a 2g, so you get a total of 4g, right? 4g minus, I'm going to take tb outside, and what is inside is 1 by m2 plus 1 by m3 plus what 2 times 2 is just 4 by m1, right? 4 by m1. Okay, so that's what I get inside. So I just want this is equal to 0. So now I can simplify this equation. I can just simplify. I can say, okay, so tb will be equal to 4g times this 1 by m1. Okay, 1 divided by 1 by m1 plus 1 by m2 m3, sorry, m2 m3 plus 4 by m1, right? So that will be tb. So I just found out tension, right? I know m1 m2 and m3, right? m1 and m2 and m3, I know for a fact that these two masses, m1 is equal to 10 kilogram, right? m2 is equal to 2 kilogram and m3 is equal to 5 kilogram. I'm going to substitute that and find out tb. So you get 4 times, right? 4 times g, I'm going to use 10, right? 4 times 10, right? Times the 1 by, so you get 1 by 1 divided by 1 by 5, 2 and 10, right? So it's 5, 1 by 5 plus 1 by 2 plus 4 by 10, right? 4 by 10, right? So that's what we get. So I can simplify that. Oh, this is going to be a bit hard. So in the denominator I get 40 times 1 by 1 divided by 10. I can take a denominator, so you get 40 times 10 by what 2 times 2 plus 5 plus 4, that is 11. So that's what you get, and approximately this will be approximately equal to some 36 newtons or something like that. Okay, 36 newtons. Okay, so that's around that it is. Okay, 4 by 11, 40 by 11 is 3.6, 4 by 11 is 3.64. Okay, 40 by 11. Okay, so that's 30 newtons. That's what you get. So tb, I found out this is equal to tb, tension in the second string, right? So in the second string, what is this thing, right? You have to realize that this is the tension in this second string tb. Now I need to find out ta, right? So for that I have a very good equation here. 2tb is equal to ta, so I just substitute that. So 2tb is equal to ta, so ta is equal to 2 times tb, that is 72 newtons, right? 72 newtons. I found out ta and tb. Oh, I got it. Now what I can use, that I know tb, which is 36 newton, I can use it in this equation, equation 3. So you get a1, a2 and a3, right? So you get a1 must be equal to g, which I am assuming is to be 10, minus 2 times 2 times, which is a1, right? 2 times tb, right? ta is equal to 2 times tb, so 2 times or 72, that's much easier, right? So 72 by what 10. So that will be around, this is a bit hard, anyways, that will be around 10 times 100 minus 72, around 2.8 or something, like 3 meter per second, or okay, so it's approximately 3 meter per second square. That's the acceleration of a1. You can calculate the exact value because you guys can use a calculator. Now a2 will be equal to g, which is 10, minus tb, which is 36 by m2. M2 was just 2 kilograms, right? 2 kilograms, so it will be around, approximately around, I think, minus 8 meters or something like that, minus 8 meter per second square. And a3 will be some value, you can, maybe you can calculate that yourself. A3 will be what? A3 will be g minus tb by m3, which is 10 minus 36 by m3 was what? M3 was, I think it's, yeah, it's 5. Yeah, it's 5 kilograms, so it's 5 kilograms. So you get approximately around 2.8 meter per second or something like that, 2.8 meter per second or 3 meter per second square. So basically what you can see is that what you can see is that the numbers tell you a2 is negative, a3 is positive, and a1 is positive. So that means, what that means is that this thing is going to go down, right? This thing, change color, this thing is going to go down, positive. This thing is going to go up, that's negative. This thing is going to go down. Okay, that's what's going to happen, right? So you can predict it just by looking at this equation. So this will go up, down, and down with the velocity, exact velocity, with the 3 meter per second here, approximately 3 meter per second square. And this goes up by 15 meter per second square, and this goes up by 3 meter per second square, goes down by 3 meter per second square. So that's what happening, that's what is exactly happening. So with that, I'm going to close this lecture. This was a very useful problem, I guess, and you guys benefited from this, all this. So please subscribe and keep watching. Okay, we will get to some bigger parts very soon.